Hello guys, so we're on the 2025 AMC10A Problem 1. So Andy and Betsy both live in Mathville. Andy leaves Mathville on his bicycle at 1:30, traveling due north at a steady 8 miles per hour. Betsy leaves on her bicycle from the same point at 2:30, traveling due east at a steady 12 miles per hour. At what time will they be exactly the same distance from their common starting point? So basically, we know that, okay, so now let's keep track of time. So at 2:30, Andy is 8 miles away, and at 2:30, Betsy is 0 miles away. At 3:30, Andy is 16 miles away, and at 3:30, Betsy is at 12 miles away. And at 4:30, Andy is 24 miles away, and at 4:30, Betsy is also 24 miles away. So they're both at the same distance, so it's E 4:30.
On the 2025 AMC10A Problem 2. So a box contains 10 pounds of a nut mix. That is 50% peanuts, 20% cashews, and 30% almonds. A second nut mix containing 20% peanuts, 40% cashews, and 40% almonds is added to the box, resulting in a new nut mix that is 40% peanuts. How many pounds of cashews are now in the box? Well, seeing this question, it's a lot of information coming at us and can be quite confusing. So let's break up each piece of information and express it into mathematical terms. So let's take the first box here. First box, it says there are 10 pounds of nut mix. So let's write it, 10 pounds. 50% of it is peanuts. 50% is just 1/2. So 1/2 of 10 is 5. So there are 5 pounds of peanuts. I'll just write 5 peanuts. And 20% are cashews. Well, 20% would just be 20 over 100, which you can simplify down to 1/5. So 1/5 of 10 pounds would be 2. So there are 2 pounds of cashews, which I'm just going to write as 2 cashews. And there's also 30% of almonds. And we already know there's 10 pounds total, and these are already 7 pounds, so we could just quickly find there are 3 pounds of almonds. So this is the first box. And now it says there's a second nut mix containing these. So let's take the second box right here. This is the second box. We don't know how many pounds of nut mix are in the second box. So let's assume there are X pounds of nut mix in the second box. So that would mean if there are 20% peanuts, 20% is 1/5. 1/5 of X would be X over 5 pounds of peanuts. And 40% cashews, 40% is 40 over 100. You divide by 20 on both top and bottom, which will lead us to get 2/5. So 2/5 of X is 2X over 5. There's 2X over 5 pounds of cashews. And there's also 40% of almonds, so that's also 2X over 5 pounds of almonds. Great. Now we have listed out both the first box and the second box. And it says they're combined together to make a resulting new nut mix. And in this new nut mix, there are 40% peanuts. What does it mean that there's 40% peanuts? That means the number of peanuts to the total amount of nut mix is 40%. So we have that right here. If we take 5 peanuts plus the new X over 5 peanuts over the whole thing, that should be 40%. So let's find what that is. Well, you know the sum of these pounds is 10, and the sum of these pounds should be X, because in total there should be 10 plus X pounds in the new nut mix. So the amount of peanuts is just 5 plus X over 5. And the total amount of nut mix should be 10 plus X. And this should be 40%, And we know 40% is 2 over 5. So 2 over 5. Now let's do some cross multiplication here to simplify it. So we have 5 times 5 plus x over 5 is equal to 2 times 10 plus x. Now let's distribute. So we have 25 plus x is equal to 20 plus 2x. And let's isolate x. So we have x is equal to 5. Is that our answer? Well, we set x to be the number of pounds of nut mix in the second box. So this is 5 pounds. So that means there's actually 1 pound of peanuts, 2 pounds of cashews, and 2 pounds of almonds. And the question asks, how many pounds of cashews are now in the box? Well, originally there were 2 pounds of cashews, and now there's 2 pounds of cashews. So we just do 2 plus 2, which gives us a result of 4 pounds of cashews in the box, which is answer choice B. The 2025 AMC10A Problem 3. So, how many isosceles triangles are there with positive area whose side lengths are all positive integers and whose longest side has length 2025? Well, the way we're going to be doing it today is all based on the triangle inequality theorem. Well, what is that? So let's take any random triangle. Let's draw one right here. Any random triangle. Say let's have this side be A, this side be B, and this side be C. Well, the triangle inequality theorem tells us that the sum of the sides A plus B must be greater than C, and likewise B plus C has to be greater than A, and C plus A has to be greater than B. Well, this helps us a lot with this question. So let's keep this in mind. So we have an isosceles triangle. That means 2 of the sides of the triangle must be the same. Well, how does that really help us? We have 2 cases in this problem. Let's have this be case 1. Case 1 is where these 2 sides are equal, and this side down here is 2025. Well, how many cases would this work? Well, we know if this length is 2025 over 2, then the sum of these 2 sides are 2025. But that isn't greater than 2025, and we know all side lengths have to be integers. So what's the next integer that can satisfy our triangle inequality here? That'd be 1013, which is actually 1 greater, or it's the ceiling function of 2025 over 2, if you know what that is. Well, let's double check if this works. Well, 1013 plus 1013 is greater than 2025, and these 2 are greater than that, and these 2 are greater than this. And we know this is the smallest value that would work. That's an integer because 1012 plus 1012 is 2024, and that's less than 2025. So we know that wouldn't work. Now, what's the largest number that would work here? Well, you could say it goes on to infinity, but keep in mind here it says the longest side length is 2025. So the longest is 2025. Because if we have this be 2026, then the longest side wouldn't be 2025 anymore. So this is the number range for that side length. And how many numbers are here? Well, because it's inclusive, we take 2025 minus 1013 plus 1, which is just 1013. But hold on, there's one other case. Let's take case 2 down here. Case 2 is if we have a triangle, an isosceles triangle, but instead of 2025 being the other side, we have the 2 equal sides both be 2025. While using our triangle inequality theorem, the minimum for this length down here would be 1. Well, I mean 1 plus 2025 is greater than 2025, and so it works. And the largest value, again, would be 2025, because it can't be larger than that, or else it wouldn't be the longest side length anymore. Wait, this has 2025 numbers in it, but we overcounted. If we take the equilateral triangle, an equilateral triangle is a triangle where all side lengths are the same. If we have the equilateral triangle 2025, 2025, and 2025, we overcounted it. We counted it in case 1 and case 2. So let's minus 1, so we have 2024 cases here. And let's take the sum of these two to find the total number of ways, which would be 3037. And this would lead us to get answer choice D. The 2025 AMC10A Problem 4. So a team of students is going to compete against a team of teachers in a trivia contest. The total number of students and teachers is 15. Ash, a cousin of one of the students, wants to join the contest. If Ash plays with the students, the average age on that team will increase from 12 to 14. If Ash plays with the teachers, the average age on that team will decrease from 55 to 52. How old is Ash? Well, first of all, if we're trying to find how old Ash is, why not just set a variable? So let's have A be Ash's age. And now let's find what else we can convert into mathematical terms. Well, we know the total number of students and teachers is 15. So let's have S be the number of students. And let's have T be the number of teachers. So we know S plus T is equal to 15. And before Ash joins the students team, let's express the average, which is 12, in mathematical terms. So we know to find the average, we take the sum of the data points divided by the number of data points, and that's our average. So the sum of the student's age divided by the number of students, which is S, is equal to 12. And we multiply by S on both sides. So the sum is equal to 12S. We can do the same for the teachers, so the sum over the number of teachers is equal to 55 before Ash joins. So the sum is 55T. But now let's calculate what the average would be once Ash does join. So once Ash joins, the original sum of the students, which is 12S, will be 12S plus A, divided by the number of students plus one more, which is Ash. And this new average would be 14. And we know that from the question. And let's do the same for the teachers. So the original sum of the teachers is 55T plus Ash over the number of teachers, which is T plus 1. And the new average is 52, and that's also from the problem. So what we want to do here is let's solve for S in terms of A. So then we can plug it back into S plus T is equal to 15 to find A. So let's first simplify this. If we multiply by S plus 1 on both sides, we have 12S plus A is equal to 14S plus 1. Let's distribute here to have 14S plus 14. So 2S is going to be equal to a minus 14. So s is going to be equal to a minus 14 over 2. And let's do the same for the teachers. So if we multiply by t plus 1 on both sides, we have 55t plus a is going to be equal to 52t plus 1. And let's distribute. So 55t plus a is equal to 52t plus 52. And isolate t, so we have 52 minus a. So t is equal to 52 minus a over 3. Let's go back to what we have here. We have s plus t is equal to 15. So we have s plus t is equal to 15. Let's take these two and plug this in. So we have s, which is a minus 14 over 2, plus t, which is 52 minus a over 3, is equal to 15. If you multiply by 6 on both sides of the equation, we have 3 times a minus 14 plus 2, 52 minus a is equal to 90. Let's distribute. So 3a minus 52, or not 52, 42 actually, plus 104 minus 2a is equal to 90. Well, the a's cancel to just a, and 104 minus 42 is actually 62. So we subtract 62 on both sides of the equation. So a is going to be equal to 28. So the question asks how old Ash is. So Ash is 28. Answer choice A. 2025 AMC10A Problem 5. So let's consider the sequence of positive integers 1, 2, 1, 2, 3, 2, 1, 2, 3, 4, 3, 2, 1, and so on. What is the 2025th term in this sequence? Well, let's look for a pattern. If you haven't seen it already, it goes 1, 2, 1, and then 1, 2, 3, 2, 1, 1, 2, 3, 4, 3, 2, 1, and so forth. So it's like 1, 2, 1, 1, 2, 3, 2, 1, 1, 2, and so forth. Well, one thing we can notice is even though we can split it at the ones, there's no repeated one. They share the same one. So let's count how many terms are here. So in this little first grouping here, we have 3 terms, 1, 2, 1. And let's not overcount this one. So we're going to start at 2, 3, 2, 1. So this little grouping has 4 terms. And then you start at 2, 3, 4, 3, 2, 1. And that's 6 terms. Here is 1, 2, 3, 4, 5, 6, 7, 8. 8 terms. And if you haven't seen the pattern right now, I'm going to guess this has 10 terms. And let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It does have 10 terms. So as you can see, besides the 3, it's just positive even integers. So let's take the sum of these actually to find the 2025th term. Say we want to find the 13th term. And say we have 3 plus 4 plus 6 is 13, so then the 13th term would just be the end of the divider here, which is 1. So let's apply that same knowledge into finding the 2025th term. Say if we take the sum 3 plus 4 plus 6 plus 8, and we take it on until some random number we don't know yet, n. And this is equal to 2025. Or it may not be 2025, but we're looking for it to be. If it is directly 2025, then we know the 2025th term is 1. But we're just trying to find what's going on here. Well, one thing we can notice is we can just write 3 as 1 plus 2. It makes our lives a lot easier. And say this is what we're trying to find. Well, one thing you can notice is the sum of this is just n times n plus 1, because it's the sum of the first n positive even integers. And one thing you can also notice is 2025 is actually 45 squared. If you simply factorize it, you can find that too. So what if we try n to be 45? So it'd be 45 times 46 is the sum, and I could just tell you 45 times 46 is 2070. Well, that isn't 2025, but this number 2070, what does it even mean? Well, this means that the 2070th term is a 1. Well, we can use that. If the 2070th term is a 1, then we can go backwards to find the 2025th term. Let's subtract. So how many terms are in between these? So 2070 minus 2025 is going to be, take 5. So there should be 45 terms in between. Well, if we look at this, it goes 1, 2, 1, 1, 2, 3, 2, 1, 1, 2, 3, 4. And by the 2070th term, it's the end of a 1, or it's the start of a new section. So if we go backwards by 45, it should get us to 45, because it would be 1, 2, 3, all the way to 45, and then it'd come down from 45. So if we go back 45, it would lead us to 45. So 45 would be the 2025th term in this sequence, which leads us to get answer choice E.
Hello guys, today I'll be going over the 2025 AMC10A Problem 6. So in an equilateral triangle, each interior angle is trisected by a pair of rays. The intersection of the interiors of the middle 20-degree angle at each vertex is the interior of a convex hexagon. What is the degree measure of the smallest angle of this hexagon? So let's first take a look at what we want. So we can first trisect this angle. Sorry, that's bad. And keep in mind that these should all be symmetric. So these should all be somewhat, well, the hexagon should be symmetric. So we get something like this shape right here. And so basically we know that these three angles are the same by symmetry, and obviously these look bigger than these angles. So we want to find that. So our desired angle is this red angle right here. So what is this angle equal to? This angle is also equal to the flip of this angle by vertical angles. And since we know this is 20 degrees, since 60 divided by 3 is 20, and each equilateral triangle has angle 60, this is 80 degrees because we have, since this triangle is equal isosceles, it's 80 degrees because 160 plus 20 is 180. So this means that this is 100 degrees by supplementary angles. This is 60 degrees, as I said before, from equilateral triangles. This is 100 degrees. And since angles in a quadrilateral have to sum to 360, this red angle plus 260 is equal to 360. So the red angle, or the smallest angle of this hexagon, is C100. Hello guys, today we're over the 2025 AMC10A Problem 7. So suppose A and B are real numbers. When the polynomial x cubed plus x squared plus ax plus b is divided by x minus 1, the remainder is 4. When the polynomial is divided by x minus 2, the remainder is 6. What is b minus a? So there are many ways to do this problem, but I decided to do the remainder theorem. And so basically, basically the remainder theorem states that if a polynomial is divisible by x minus r, then plugging in r into the equation will yield 0. So now let's use this to our advantage. So let's plug in 1 into the polynomial, then we get 1 plus 1 plus a plus b. And we know this should be equal to 4. And plugging in 2, we get 8 plus 4 plus 2a plus b, and this should be equal to 6. So here we have a plus b is equal to 2. and here we have 2a plus b is equal to -6. So now let's subtract the two equations. We get a is equal to -8 and b is equal to 10 from these two equations. And so now b minus a is equal to 18. Hello guys, so you go over the 2025 AMC10A Problem 8. So Agnes writes one of the following 4 segments on the blank piece of paper. At least one of these statements are true. At least 2 of these statements are true. At least 2 of these statements are false. And at least 1 of these statements are false. Each statement is either true or false. How many false statements did Agnes write on the paper? So let's first say that Agnes wrote 0 false statements on the paper. Well, that's not possible because at least 2 of these statements are false would have to be a true statement. So now we know that at least one of the statements have to be false. So let's say now we have 3 truths and 1 lie. So let's see. At least one of these statements are true. 3 is at least 1, so that's true. At least 2 of these statements are true. That's true because 3 is greater than 2. At least 1 of these statements are false. That's also true because there's 1 F. And at least 2 of these statements are false. No, there's only 1 F. So that's not true. And so now obviously this satisfies, so 1 is our answer. And just to clarify, this is true, this is true, this is false, this is true. And so guys, taking over the 2025 AMC10A problem 9, so let f of x be 100x cubed minus 300x squared plus 200x. For how many real numbers a does the graph of y is equal to f of x minus a pass through the point 1, 25? So let's plug in 1 and 25 into the equation. We get 100 times 1 minus a cubed minus 300 times 1 minus a squared plus 200 times 1 minus a, and this is equal to 25. And so now, dividing by 100, we get 1 minus a cubed minus 3 times 1 minus a squared plus 2 times 1 minus a, and this is equal to 1/4. And so now we can see this is a cubic, which means that there should be 3 roots. And just like, I guess you could use rational root theorem. No, you can't use rational root theorem here. But just using some like intuition, you can figure out that, hey, all of these numbers should be real. And so obviously that's 3 numbers. And you can also do this with intermediate value theorem where you find, let's say you plug in 0 and we get 1 minus 3 plus 2 minus 1/4. And this is -1/4. And then if 1 is like 1/4, then we know there has to be a root between 0 and 1. Okay, so hello guys, today we're going over the 2025 AMC10A problem 10. So I'll actually be going over 2 ways to do this problem. So a semicircle has diameter AB and chord CD of length 16 parallel to AB. Smaller semicircle with diameter on AB and tangent to CD is cut from the larger semicircle as shown below. What is the area of the resulting figure? So first of all, this is just the easier. This is the longer solution. And so basically we have R here for the semicircle. This is 8 because we set R in the middle, and so basically this will be 64 plus R squared and the square root of that by Pythagorean theorem. So now we have R squared plus 64 pi over 2 minus R squared pi over 2, and this is just 64 pi over 2 or 32 pi over 32 pi. Another way we can do this is it doesn't specify how large R has to be. We can just size down this semicircle smaller and smaller and smaller until it's just a dot. And so until then, BC will turn into AB. And so that means that the diameter is 16 and that means that the area is 64 pi over 2, 32 pi as well.
Hi everyone, welcome to Pi Academy. Today we're going to be doing the 2025 AMC10A Problem 11. So the sequence 1, X, Y, Z is arithmetic. The sequence 1, P, Q, Z is geometric. Both sequences are strictly increasing and contain only integers, and Z is as small as possible. What is the value of X plus Y plus Z plus P plus Q? Well, let's take a look at both our sequences here. So we have one sequence being 1 X, Y, Z. And we have another sequence being 1 P, Q, Z. So let's see what we can use. Well, we know 1 X, Y, Z is arithmetic. And we know in an arithmetic sequence there is a common difference between the terms. Let's set this difference to be A. If the difference is a, then that means x must be 1 plus a. That means y must be 1 plus 2a, and z must be 1 plus 3a. So let's write that down. Z is equal to 1 plus 3a. We can use this information because there is z in both sequences. Now let's see the geometric sequence. We know geometric sequences also have a common factor in them, like it will increase by the same factor each time. Let's set this factor to be, for example, d. Then p would be 1 times d, which is d, q would be d squared, and z would be d cubed. So z is equal to d cubed. Because they both have z, we could just set 1 plus 3a is equal to d cubed. And we want to find the smallest value of z. That would mean we want to minimize a and d. But the thing is, this sequence in both sequences have to be strictly increasing. That means both a has to be positive and d cannot be fractional. So let's use that. Let's try some numbers. Let's try d is equal to 1. If d is equal to 1, then 1 plus 3a is equal to 1. So then a would be equal to 0. Is that our smallest value? Notice that when a is equal to 0, the sequence isn't increasing, because if a is equal to 0, x is 1, y is 1, and z is 1. That isn't increasing, they're all just 1. So this doesn't work. Let's take the case where d is equal to 2. So 1 plus 3a is equal to 8. So 3a is equal to 7. That doesn't give us an integer value for a, so that doesn't work either. Let's try d is equal to 3. So 3 squared is 27, so 1 plus 3a is equal to 27. So 3a is equal to 26. 26 isn't divisible by 3, so that doesn't give us an integer value of a either. Let's try d is equal to 4. Then d cubed would be 64. And that's equal to 1 plus 3a. So 3a would be 63, so a is equal to 21. That's an integer value. So we have a is equal to 21 and d is equal to 4. Is that what the question's asking us? The question asks what is x plus y plus z plus p plus q. So let's find these. Well, let's take a look at our sequences here. We have 1 x, y, z. Let's find the value of each. Well, we know a is just 21. So 1 plus a would be x, and that's 22. Y is 43, and z is 64. Let's take a look at 1pqz. We have 1pqz. The common factor here is 4. So we would have 1, 4, 16, 64. These are our two sequences. Now let's take a sum of x plus y plus z plus p plus q. So this is x, this is y, this is z, this is p, and this is q. Let's add them. We know 4 plus 16 is 20. We know 22 plus 43 is 65. And then let's take 65 plus 20. That's 85. Now we take 85 plus 64, and that is 149. So our answer is 149. And that leads us to that would get us our answer. Today we're going to be doing the 2025 AMC10A Problem 12. So Carlos uses a 4-digit passcode to unlock his computer. In his passcode, exactly one digit is even, exactly one, possibly different, digit is prime, and no digit is 0. How many 4-digit passcodes satisfy these conditions? Well, let's take a closer look at the conditions. If exactly one digit is even, what are the choices? let's look at the even digits. Well, it can't be 0 because there's no 0. So it'd be 2, 4, 6, or 8. And exactly 1 prime. That would be 2, 3, 5, or 7. Well, one thing we can notice is there's 2. 2 is both even and prime. We have to take that into consideration later. And how many digits are neither prime nor even? Well, 1 and 9. So let's take a look. If 2 is both even and prime, we can't have 2 be the even, or else there would be more than 1 prime. So let's take this into two cases. In case 1, we have a 2. And in case 2, there is no 2. So in case 1, if we have a 2, then that satisfies there's only 1 prime and there's only 1 even. So if we have a 2, we could put it in 4 different spots. And for the other 3 spots, we can either choose 1 or 9. So that would be 2 cubed. Because this has 2 choices, this has 2 choices, and this has 2 choices. So this has a total of 32 choices. Now we have to take case 2, where there's no 2. So we have our 4 digits, and besides the 2, there are 3 evens. So there are 3 ways we can choose an even number. And besides the 2 in the primes, there's also 3 ways we could choose a prime. Now we have to see how many ways are there to choose a 1 or a 9. Well, let's see. If we already chose an even and we already chose a prime, how many ways are there to order it? Well, we know, let's say we chose the even, and there are 4 ways to place down the even. So we will have 4 times 3. And say we have 3 choices for the prime. Say the even's already here, then we only have 3 choices to where the prime is put. Now we have these 2 places left. Now we can choose either 1 or 9. So we have 2 squared here. And now let's simplify it. We know this is 12, this is 9, and that's 4. So basically what we have here is 36 times 12. 3 times 144. We can do the multiplication here. 144 times 3 is 432. 432 cases for case 2. And let's take the sum of case 1 and case 2 to find the total number of possibilities. And that'd be 464. So let's take a look at our answer choices, which gets us answer choice D.
Hello guys, going over the 2025 AMC10A Problem 13. So the outside square considers infinitely many squares, each of them with the same center and sides parallel to the outside square. The ratio of the side length of a square to the side length of the next inner square is k. And so basically the area of the shaded portion is 64% of the area of the original square. What is k? So basically, let's say the outside square has side length 1. Then the inside square is k, the inner square is k squared, and the inner square is k cubed. So then the areas are 1, k to the k squared, k to the 4th, and k to the 6th. So now what is the shaded area? The shaded area is 1 minus k squared plus k to the 4th minus k to the 6th plus all the way down. And so this is just an infinite geometric sequence. This is just 1 over 1 plus k squared. And this is equal to 64 over 100. So now cross multiplication gives us 100 equals 64 plus 64k squared. And now this yields k squared is equal to 9 over 16, or k is equal to 3/4. So thank you guys for watching.
Today we're going to be doing the 2025 AMC10A Problem 14. So 6 chairs are arranged around a round table. 2 students and 2 teachers randomly select 4 of the chairs to sit in. What is the probability that the 2 students will sit in 2 adjacent chairs and the 2 teachers will also sit in 2 adjacent chairs? Well, let's see. Something special about this question is it says they are arranged around a round table. What's special about a round table? Well, in a round table, you can rotate the seats and rotate the seating. So the key idea here is, say we have 6 seats. 1, 2, 3, 4, 5, 6. We have to put one student or one teacher down to anchor the table. So let's have S1 be student 1, S2 be student 2, T1 be teacher 1, and T2 be teacher 2. So let's just put S1 right here to anchor the table down. It doesn't really matter that we put S1 here, because S1 being here versus there, it all doesn't matter. Now that we've anchored down the round table, now it matters that either someone's to the right of S1 or someone's to the left. Now the order does matter. So that's the key part to doing this problem. So now we want the total ways that we can sit everyone down. So the total ways we can have S2, there are 5 choices. 1, 2, 3, 4, 5. So we have 5 choices for S2. And likewise, once S2 sits down, there are 4 choices left for T1 and T2. Once T1 sits down, there are 3 choices left for T2. So the total number of ways we can sit them down is 60, because we multiplied them. But now we want to find how many ways are there that the 2 students will sit next to each other and the 2 teachers will also sit next to each other. Well, if we want student 1 and student 2 to sit together, there are 2 choices for where S2 can sit, either to the left or to the right of student 1. So there are 2 choices. Say let's sit S2 right here. Now we want to find how many ways S1 and S2 can sit together. Well, this is kind of tricky, but one way we can think about this is, let's make sure T1 and T2 always sit together. So let's consider T1 and T2 as a big block. So we can either sit the block here, here, or here in order for them to be next to each other. So there are 3 ways. So T1 and T2, there are 3 ways. But notice we can also change the order. It can be T1, T2, or it could be T2, T1. So we have to multiply this by 2. So there are 6 choices here. So let's take these 2 and we multiply them. So there are 12 choices, or 12 ways we can seat them. So S1 and S2 sit together and T1 and T2 sit together. So if we take the 12 ways that satisfy our conditions over the total number of ways, which is 60, we get 1/5. So 1/5 of the time the students sit together and the teachers sit together too. So that gives us answer choice B. Today we're going to be doing the 2025 AMC10A Problem 15. So in the figure below, ABEF is a rectangle. AD is perpendicular to DE. AF is equal to 7, AB is equal to 1, and AD is equal to 5. What is the area of triangle ABC? So at first, looking at this might be pretty difficult, because how are we supposed to find that? Well, let's write down what we know. So we know AF is 7, and we know AB is 1, and we know AD here is 5. And we want to find the area of ABC. Well, we know this is a right angle because it's part of a rectangle. So if this is a right angle, we know if we find BC, we can find the area because it'd be the height multiplied by a base. So let's set BC as x. Using Pythagorean theorem, we can find AC. Let's write it over here. Say AC would be the hypotenuse. So using Pythagorean theorem, the square root of AC would be the square root of 1 squared plus BC squared. And BC is x, so it would be 1 plus x squared. So that's AC. Then using AD is 5, we can find CD. CD would just be 5 minus root 1 plus x squared. Well, what else can we use? We know EB is also 7 because AF is equal to BE because it's a rectangle. So, if BE is 7, what is EC? Well, you minus x because BC is x. So, EC would be 7 minus x. So, what can we do now? Let's clear up our graph here so it's a little more clear. So, we want to find what BC is. We want to find x. Well, what's something we can use? Notice that this is a right triangle and this is also a right triangle. So, can we use similar triangles? Well, let's take a look at triangle ABC. Is this similar to anything? Well, we know ECD, this angle, is equal to ACB because they're at an intersection point. Using AAA similarity, we can find that ABC is similar to this here, is similar to triangle EDC. And how can we use this to help us? Well, let's create a ratio of the side lengths that we do know. Well, DC here is, or CD here is 5 minus root 1 plus x squared. We can take this length, right here. If we take this length over EC, which is the hypotenuse, EC is 7 minus x. The ratio of these side lengths, let's take a different color here. The ratio of these side lengths should be the same as the ratio of CB to AC. Well, what's CB? CB here we have is x over CA, AC, which we set as 1 plus x squared. Perfect. Now we have an equation to solve for x. Now let's solve. Let's take cross multiplication to simplify it. So we have x times 7 minus x is equal to root 1 plus x squared times 5 minus root 1 plus x squared. Let's distribute on both sides. So we have 7x minus x squared is equal to 5 root 1 plus x squared minus 1 plus x squared. Well, technically it'd be that. So notice that we have negative x squared on both sides of the equation. So why don't we just add x squared on both sides? So we have 7x is equal to 5 root 1 plus x squared minus 1. This is a lot simpler, but let's take the square on both sides so that we can get rid of the square root. So let's first move the 1 over here, and now let's square both sides. So if we square this, and we square this, 7x plus 1 squared is 49x squared plus 14x plus 1. Let's square this side, so it's 25 times 1 plus x squared. Let's distribute the 25, so we have 49x squared plus 14x plus 1 is equal to 25 plus 25x squared. Well, this is just a quadratic equation. Let's move everything to one side to keep it clear. We have 24x squared plus 14x minus 24 is equal to 0. Well, let's clear up some space here so we can solve this quadratic. So, once we clear this up, let's factorize our quadratic here to help us simplify. Well, we can factorize. First, why don't we divide by 2 on both sides of the equation to keep it easy. So 12x squared plus 7x minus 12 is equal to 0. Well, how can we factorize this? There's many ways we can solve this quadratic equation, but since we can factor, let's try this first. Well, if you didn't notice, this should be the factorization, because negative 3 times 4 is negative 12, and the other terms will add up to 7x. So if we solve this, x is either equal to negative 4 over 3 or 3 over 4. Well, we know x can't be negative because we're working in geometry and it can't have a negative length. So x is 3/4. Is that our answer? Well, no, we're trying to find the area of ABC. Now we have AB is 1. 1 times 3/4 over 2 to find the area is 3 over 8. So our area is 3 over 8, which gives us answer choice A.
Hello guys, so you know the 2025 AMC10A Problem 16. So there are 3 jars, each of whose 3 coins is placed in one of the 3 jars, chosen at random independently of the placements of the other coins. What is the expected number of coins in the jar with the most coins? So first of all, expected value is something like E of x is equal to 3 times the probability that 3 is the maximum, plus 2 times the probability of that 2 is the maximum, plus 1 times the probability that 1 is the maximum. And this is just how expected value works. Let's handle these case by case now. So case 1, 3 is the maximum. Then our jar should look like 3, 0, 0, where 3 represents how many coins are in that jar. So there are 3 ways to choose which coin has 3, and which jar has 3 coins in it. And out of there, we have 1 over 27 ways to put the coins in. So now we have case 2, which is 2. So now we have 2, 1, and 0 as our jars. There are 6 ways to arrange these. And in those, we have 3 ways to choose which coin is going to be in the 1 jar. So now 1 over 27 to arrange them as well. Now last case, case 3, is that 1 is the maximum, which means that we have 1, 1, 1. And so from here, there's one way to just choose them. And then now the first coin has 3 out of 3 choices to go. The second coin has 2 out of 3 choices to go. And the last coin has 1 over 3 choices to go. So this is just 2/9. So now our total is just 3 times 3 times 1 over 27, plus 6 times 3 times 1 over 27, times 2, and then 3 times 2 all over 27. So let's cross things out. Wait, I don't know what that is. Let's cross things out. So this is equal to 1/3. This is equal to 1/9. So we have 1/3 plus 4/3 plus 2/9. And this is just equal to 17 over 9. And that means our answer is 17 over 9D. Hello guys, today I'll be going to 2025 AMC10A Problem 17. So let n be the unique positive integer such that dividing 273,436 by n leaves a remainder of 16, and dividing 272,760 by n leaves a remainder of 15. What is the tens digit of n? Alright, so first of all, we know that 273,436 is equal to 16 mod n. And 272,760 is equal to 15 mod n. This means that, let's subtract these two numbers. This gives us 676 is equal to 1 mod n. So 675 is equal to 0 mod n. So what does this mean? This means that n is, this means that n is equal to some number that's some one of 675's divisors. And so this would be 1, 3, 9, 27, and 5, 25, and some overlap of these numbers as well. So now let's look back into this. Let's first look at this bottom equation. 272,745 is equal to 0 mod n. Let's first divide by 5 and see what happens. Dividing by 5, we get 5. Actually, yeah, let's just draw the dividend. So we get 5, 25, 22, 4, 5, 4, 9. So 54549. Obviously, this is not divisible by 5, so n can't be 25 or any multiple that has 25 as a factor. So that's interesting. And on top of this, let's also view 27. We have 272745. Let's divide by 9 here. We get 30305. 30305 is not divisible by 3 because of the sum of digits rule. 6 plus 5 is 11, which is not divisible by 3. So 27 can't be a divisor. So now we're left with this pool. And we know that since n has a tens digit, we can automatically eliminate the ones with 1 digit. So the only ones we have left are 15 and 45 that are 2 digits. And obviously, since it has a remainder of 16, it can't be 15. So our answer is 45, tens digit 4. Hello guys, so you go to the 2025 AMC10A Problem 18. So the harmonic mean of a collection of numbers is the reciprocal of the arithmetic mean of the reciprocals of the number in the collection. For example, the harmonic mean of 4, 4, and 5 is 30 over 7. So what's the harmonic mean of all the real roots of this 4,050th degree polynomial? So our number is going to be 1 over, there's 4,050 roots, times all the roots reciprocals. And so now let's take them all under a common denominator. This will be all the roots multiplied together, and then over R2, R3, plus R1, R2, so something like that. And so we know that by Vietas, this is the constant term, and this is the term with degree 1. And so now let's take a look at this equation. So the constant term will be negative 3 to the 2025 because we can just multiply every single constant. And since it's a 4,050th degree polynomial, we have to negate this. So this is 1 over 4,050 times the constant term is 3 to 2025. So now what's the subconstant term? We can achieve a subconstant term by, let's say, taking negative 4x and then multiplying it by every other negative 3. So what would that be? That would be negative 3 to the 2024 times negative 4. And since there are 2025 4 terms, this is 2025. So now this is going to be our answer all over 1. So this will be negative 3 times negative 3 over 2. Wait. So no, this is not negative 3 over 2. This is negative 2 over 3. And so taking the reciprocal, this is negative 3 over 2, which is our answer. Hello guys, you can go to the 2025 10A problem 19. So an array of numbers is constructed, beginning with the numbers negative 1, 3, and 1 in the top row. Each adjacent pair of numbers is summed to produce a number in the next row. Each row begins and ends with negative 1 and 1 respectively. As the process continues, one of the rows will sum to 12,288. In that row, what is the third number from the left? So the sum of the first row is 3, the sum of the second row is 6, and the sum of the next row is 12. So we know that the sum of row n is going to equal 3 times 2 to the n minus 1. And so since 12,288 is equal to 3 times 4,096, this is just row 13. So we want to find the third number from the left in row 13. So let's take a look at this. So we have 1, 3, 1. Then the next row will be 1, negative 1, 2, and no, negative 1, 0, and 2. Then after that, negative 1, negative 1, 2, negative 1, negative 1. Wait, cut that out. Alright, so now we have negative 1, 3, 1. After that, we have negative 1, 2, and 4. Negative 1, negative 1, 1, and 6. Negative 1, 0, 7, negative 1, negative 1, 7, negative 1, negative 1, 6. No, negative 1, sorry, negative 2 is here. Negative 1, negative 3, 4, negative 1, negative 4, 1, negative 1, negative 5, negative 3, negative 1, negative 6, negative 8, negative 1, negative 7, negative 14, negative 1, negative 8, negative 21, and negative 1, negative 9, negative 29. This is going to be our answer. Hello guys, so I'm going to 2025 AMC10A Problem 20. So a silo, right circular cylinder with diameter 20 meters stands in a field. McDonald's is located 20 meters west and 15 meters south of the center of the silo. McGregor is located 28 meters east and G meters south of the silo. The line of sight between McDonald and McGregor stands at the silo. The value of G is A root B minus C over D. Find A plus B plus C plus D. Alright, so this is kind of what our graph is. We have 20 over here and 20 over here. We have G G over here. We have 15 right here. And so now we know this is the radius is 10. So now we can do a little bit of quick maths. So let me erase that line real quick. Basically, let's make this line right here and this line right here. Now these are both 90 degrees. So now we know this is 10. So now we know that this angle is equal to 400 plus g squared, square root of 400 plus g squared. And this length is equal to square root 625. So now by Pythagorean theorem, we know that these two purple lengths is going to be equal to square root g squared plus 300 plus square root of 525, just by Pythagorean theorem alone. Now, how else can we express this? Let's move this length of 20 up. So now this red length is 40, and this length is 15 minus g. So by Pythagorean theorem, this purple length is also equal to g squared minus 30g plus 225 plus 1600. So we know that, and the square root of this. So now this is equal to g squared plus 825 plus, by FOIL, 2 root 525 times g squared plus 300. We can cross out. This leads us to negative 30g plus 1000 is equal to 2 root 525 times g squared plus 300. So let's divide by 2 on both sides. Negative 15g plus 500 is equal to 525 times g squared plus 300 times g squared plus 300 and the square root of that. So let's square both sides. Now we have 225g squared minus 15,000 g plus 250,000 is equal to 525 g squared plus 525 times 300. So now we have 300g squared. Let's subtract these on both sides. Plus 15,000g. And now let's divide by 100. So 100, 100, 100. So now we have 3g squared plus 150g minus 2500 minus 525 times 3. So now what is that? That's negative 925. So hold on, let me just add a page. We want to find g, since that g is the solution to 3g squared plus 150g minus 925 is equal to 0. So by the quadratic formula, this is negative 150 plus, obviously can't be minus, otherwise g would be negative, and 150 squared plus 4 times 3 times 925, all over 6. Let's first factor out a 4. Let's first divide by 2. This is negative 75 plus, now we have to factor out a 4 from the inside, which would make this 75 squared plus 3 times 925, all over 3. Now let's factor out a 5 from the square root. Negative 75 plus 5 root 225 plus 3 times 925 divided by is 37, all over 3. So now 3 times 37 is 111. And so adding this together is 336. So negative 75 plus 5 root 336 over 3. Now we know that 336 is equal to 16 times 21, so we can factor out a 4. So this is our final answer, and this means that 20 plus 21 plus 3 plus 75, which is equal to 119. Hello guys, so you're going to the 2025 AMC10A Problem 21. So a set of numbers is called sum free if whenever x and y are not necessarily distinct elements of the set, x plus y is not an element of the set. So what is the greatest possible number of elements in a sum free subset of 1 to 20? So we notice that for, let's say we have 2, 4, and 8, 2, 4, 6. Well, we can't have even numbers because we can always get from 2 to 4, or let's say 6 and 12, we can always get from that. But conversely, if we have 1, 3, and 5, we can't double 1 to get to 3. So we immediately notice like this, that even numbers are bad. And so pretty much that's literally all we have to figure out for the problem. Since we can't have any even numbers, we have 1, 3, 5, all the way to 19. And obviously none of these numbers can add to each other because odd plus even is equal to odd, and odd plus odd will never add to any one of these. So 10 is a safe number, and that is our answer. Hello guys, so 2025 AMC10A Problem 22. A circle of radius r is surrounded by 3 circles whose radii are 1, 2, and 3, all externally tangent to the inner circle and externally tangent to each other as shown in the diagram below. What is r? So we don't actually have a diagram for this problem, but basically it's like, on the test it was something like this. With that. And obviously the diagram doesn't really matter. What we're going to use is called Descartes' circle theorem. Basically, this theorem states that like any 4 circles that are tangent must satisfy this equation. So basically, they state curvatures, which are just the reciprocal of the radius. So basically, we have 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over r squared must be equal to 2 times 1 over 1 plus 1 over 4 plus 1 over 9 plus 1 over r squared. So now let's expand this. So we have 11 over 6 plus 1 over r squared. And this is equal to 98 over 36 plus 2 over r squared. And so now let's expand this. We have 1 over r squared plus 11 over 3r plus 121 over 36. This is equal to 98 over 36 plus 2 over r squared. So now we have 1 over r squared is equal to, what's 121 minus 98? That should be 23. Yeah, 23 over 36 plus 11 over 3r. Now let's multiply by 36 on both sides. We have 36 over r squared is equal to 23 plus 132 over r. Let me actually add a new page real quick. Now let's multiply by r squared on both sides. We have 23r squared plus 132r minus 36 is equal to 0. Now Pythagorean theorem time. Wait, what am I saying? Quadratic formula. R is equal to negative 132 plus 132 squared minus 4 times 23 plus times 36 all over 46. And also we have plus minus here. So now basically let's first factor out 4, and that turns us into negative 66 plus minus 66 squared plus 23 times 36 all over 23. Now let's factor out 6. This is negative 66 plus minus 6 root 121 plus 23 all over 23. This is just 12 squared. 121 plus 23 is 144, which is 12 squared. This is negative 66 plus minus 72 all over 23. And so obviously this can't be negative, so this is 6 over 23. Hello guys, today I'm going to go with 2025 AMC10A Problem 23. So triangle ABC has side lengths AB is equal to 80, BC is equal to 45, and AC is equal to 75. And so the bisector of angle B and the altitude of side AB intersect at point P. So what is P? What is BP? Okay, so now let's let this angle be Q. Okay, point BQ. So let's first find the area of ABC. So the area by Heron's theorem, Heron's formula, we know that semi-perimeter is 100 by adding them all up and dividing by 2. And we have to take the square root of this times 20 times 25 times 55. So let's take out a 10. Now we can take out another 5. And we take out another 5. And we can take out another 2. Just for a result of 500 root 11. So this is our area. So this means that CQ is equal to AB. CQ is equal to 2 times area over AB. So that means it's equal to 1000 root 11 over 80, or 25 root 11 over 2. So now we can use the angle bisector theorem, but before we use that, let's do Pythagorean theorem to find BQ. So Pythagorean theorem on BQC, we have 45 squared, which is 2025, minus 625 times 11 over 4. 625 times 11 is 625, 625, 6875 over 4. So now we have 8/100 minus 6875 for 1225. So BQ is equal to 35 over 4 over 2. So now we can do angle bisector theorem. Basically, angle bisector theorem tells us that QP to PC is equal to 7 to 18 because this is 7, 18 in the ratio. So we know that QP is equal to 7 over 7 root 11 over 2. Alright, so now let's do Pythagorean theorem on BQP, and now we find BP. So we get 1225 over 4 plus 49 times 11 over 2. This is 1225, oh sorry, not over 2, over 4. 49 times 11 is 539, so we get 1764. And that divided by 4 is equal to 441, and we all know that square root of 441 is equal to 21. So BP equals 21 is our answer. Hello guys, so it's 2025 AMC10A Problem 24. So call a positive integer fair if no digits used more than once, it has no zeros, and no digit is adjacent to two greater digits. For example, 196, 23, and 12,463 are fair, but 1,546, 320, and 3,400, 321 are not fair. How many fair positive integers are there? Let's say we have now let's do casework on like the greatest number, right? So for example, let's say the greatest number is n. Then we must have on both sides of the equation both sides of the number we must have a strictly increasing and strictly decreasing. And so basically for every number we have three choices. We can either put it in the increasing pool or the decreasing pool, or outside the number, not included at all. And so this is just 3 to the x, where x is the number of digits included. And this is fine because there's only one ordering of, let's say, 1, 3, 4, 5, and 7 to put them in increasing order or decreasing order, so you don't have to worry about that. So a closed form is just 3 to the x. So now let's do casework on what the greatest digit of n is. So let's say n is equal to 1. So this means that this is 3 to the 0, as there aren't any other digits we can put in. If n is equal to 2, then we have 2, and then 1 can either be in front of 2, behind 2, or not included in the number at all. So that's 3 to the first. That's 3. We have 1 and 2. 1 can be included. 1 has 3 choices and 2 has 3 choices, so 3 squared. And so we can continue this all the way down until 9 is the greatest digit, and then we have 3 to the 8. And so basically, in total, the sum of this by sum of a geometric series is 3 to the 9 minus 1 over 3 minus 1. This is equal to 3 to the 9 minus 1 over 2. So now the question is, what is 3 to the 9? And I'm sure in the real contest you could figure this out, but it is 19,683. So we want 19,683 minus 1 over 2, or 19,682 all over 2. And so just by intuition alone, it's C. Hello guys, yeah, I'll be going over the 2025 AMC10A Problem 25. A point P is chosen at random inside square ABCD. For the probability that AP is neither the shortest nor the longest side of triangle APB can be written as A plus B pi minus C root D over E, where A, B, C, D, and E are positive integers. GCD of A, B, C, E is 1, and D is not divisible by the square of a prime. What is A plus B plus C plus D plus E? Okay, so we have a square, right? So basically, let's set the side length to 2, and you'll see why later. But basically, we have two cases. And let's let AP equal to A and BP equal to B, just to save ourselves some time. So we have 2 is less than A less than B, or B is less than A less than 2. So let's first look at 2 is less than A is less than B. So for A to be less than B, then the locus of points has to be on this side of the rectangle, because then PB is always longer than PA. On top of this, since A is greater than 2, A is outside the locus of this circle, where this circle is the amount of points where A is less than 2. So this is the shaded area for case 1. And now for case 2, A is greater than B, so it has to be on this side of the thing, and A is less than 2, so A has to be this sector right here. And so now we have figured out what areas we are looking to solve for. So now let's do it. So now we set it to 2 because now this is 2 and 1, and since we know that this is an equilateral triangle right here, this is also 2, this is 60 degrees, and this is 30 degrees. So let's first find the area of this thing right here. So that will be 2 minus 30-degree sector of a circle with 4 pi, which is just pi over 3, and minus root 3 over 2. And now this bigger area over here, that will just be, well, first of all, the area of this red thing is needed, and this red thing plus this green thing equals 4 minus pi. So the red thing is just equal to 4 minus pi minus this. So this is 4 minus pi minus 2 plus pi over 3 plus root 3 over 2. And then we want 2 minus this, so we want 2 minus 4 plus pi plus 2 minus pi over 3 minus root 3 over 2. So what we get from this is we get negative 2 pi over 3 minus root 3 over 2. And we want to add this to 2 minus pi over 3 minus root 3 over 2 for the total area. This is just 2 minus pi minus, wait a second. Sorry, this is positive 2 pi over 3. So this is minus pi over 3 minus root 3. So this is just 6 minus 3 root 3 minus pi over 3. Since the total area is 4, we have to take it over 4. So 6 minus 3 root 3 minus pi over 12. It's our final probability. Adding up all the coefficients, we have 6 plus 3 plus 3 plus 1 plus 12. This will be 25, and that is our answer. Thank you guys for watching. Enjoy this video. Make sure to like, subscribe, and peace.